Hello guys, so today we are going to solve another lead code problem that's going to be aimed on grouping anagrams. So if you don't know about the anagram problems, I would definitely like request you guys to check out my other video that is actually like specifically aimed towards like this kind of problem. Let me just show you. 1 minute. So this is the valid anagram problem. Definitely do check this out in your free time if you want to understand these the crux of these problems. So let's get back to our problem at hand. So in this problem, we are given a statement where we are given an array of strings where we want to group those um, strings into a group of anagrams. So anagram is so just to recap, anagram is just a string that if rearranged, it actually results in the same string. For example, let's say if we talk about this let's talk about these string that is nat and tan, right? So let's say we have tan and we have nat, right? If you look closely, if you just rearrange these two characters or just sort the string out, you will actually get the same string. So if I, for example, let's say sort this out in in alphabetical order, I would get like A, N, and T, right? And similarly, I would get the same thing from here as well. So this is how anagram is supposed to be. If we rearrange these characters, it would definitely be the same string. So now what we need to do is to what solutions that we have to result in this kind of a thing. Let's just go into the problems one more time to actually understand it more clearly. So we have eat. We don't it resonates with the T as well. It's the same set of characters, so we actually group this together. And then if we talk about eight, it's the same thing. We group this together. We have a group of like three strings together as anagrams. And if we talk about 10, 10 and Ned already discussed our group of anagrams, then we are left with bad. Bad is the singular anagram here. So this is how we are going to proceed. So we have two methods to resolve or solve this problem. One method is about what we can do is to simply, let me just write this down here. What we can do is to brute force method is going to be, we are going to iterate this array, sort these elements out. We're going to use, let me just show you. What we're going to do is to iterate this array. Then what we're going to do is to sort the element, like sort or like reorder, like what I've done before. Like you can reorder E to A E T, and just use it as a key and use it as a key for our hash map. And then what we can do is to simply append the upcoming LMs into the list, right? For example, what can happen is, for example, let's say I have a element called eat, right? I have an element eat. I'm going to reorder. For example, just going to follow the steps above. I'm going to reorder it to as AET, right? AET. And then what I'm going to do is to store, for example, if I have a hash list, I'm going to use the AET and append EAT into it, right? This will solve the problem, but it's going to take, like, if you calculate the time complexity, we are going to iterate this m times. If we consider this array as, let me just write this with a pencil here. If we consider this as like m here, right? And if we consider like sorting these elements, for example, if we have M, then we're going to like sort these elements. We're going to like have a time complexity of n log n. For example, if this string like has n elements, and we're going to consider n, and also the sorting mechanism is going to take n log of n times, right? So this is going to be the complexity of this, right? M, and let me just write this down. So we are going to have m n log of n time complexity. This is going to be the thing. And if we talk about space complexity, we are not actually like modifying anything. Like sorry, we are actually modifying like we have a hash list that we are storing in these things into. So we have like complexity of O of n, because we're just like appending these elements into in the same elements into our like into our hash list, right? So we are going to get O of n complexity. So now the question is, do we have a better solution than this? Obviously, I'm going to show you the solution for this thing. Let me just show you. I have the solution ready for this because I'm not going to, implement this again. I'm going to show you another solution that is far better than this. So we have the hash map. We are going to iterate string as I told you earlier. We're going to sort this key, right? Sort this key, and what we're going to do is to append the elements into the sorted key, right? This is the easiest solution, I would say. It's a very straightforward, easier solution, but obviously we have to optimize our solution a lot better. So now let's go into the other solution that we have. So in the other solution, the hashmap method, this is also the hashmap method, but with the brute force technique. In this hashmap method, what we are going to do is to like, let me just show you hashmap. What we're going to do here, if you actually rehearse the anagram problem that we discussed earlier, what we are going to do, let me just draw here. We are going to count like these elements, because if you actually see a little bit closer here, if you actually analyze this a little bit closer, what you can see, we are actually dealing with only, let me just erase it 1 minute. If you look closely, we are only dealing with characters, alphabets from like that are small cased from A to Z, right? This will give you a lot bit hint like how we can actually optimize the time complexity here. We are dealing with only characters from A to Z, and if you actually get a count of those unique characters, for example, let's say if I get a count of, let me just show you. For example, if I talk about if I talk about like key and value. If I talk about like let's say we have the count of eat, for example, E, A, T, right? We have count one, one, one. If you iterate a bit like into the next element, we have the same count for this as well, right? I think that you get the idea what I'm talking about. We can use this as our key. We can use this hash map as our key to store, to align those group of elements together. For example, if I have this hash map here, uh, so this is going to be looking like this, for example. If we have this as a key, we are using, for example, a dictionary here, right? We're going to call it dict. And now this is going to be used as our key. It's going to be a little bit weird, but I know. So it will make it a lot easier for us. And then we are simply going to like store these elements eat and t into our place like this. because obviously we have the key values, and this is going to be the same thing. So we have no problem in solving this kind of problem, and it would be a lot easier. And then we can just simply at the end of the day return these lists in our like program as well. So let's go into our like lead code and solve this problem there. Let me just erase the previous solution. So now um, let's start with our hash map. We are going to initiate our hash dictionary here. And we're going to this time use default dictionary because we want to initialize the list within the dictionary as a default value. So do you actually use this kind of a dictionary then? And then what we're going to do, and also like let me just go back and like reverse the the time complexity here as well. So the time complexity is going to be um like let me just write this down. This hashmap method is going to cost us like O m dot n time complexity. Because we're going to use two loops. One loop is going to be for iterating this m length array, and then we're going to use another loop to get these hash values in, right? We're going to count these hash values because we are not going to use any sorting mechanism, something like that. And this is going to cost us O of m n times, right? We are actually like uh, escaping this kind of a thing. And the space complexity, I think so it's going to be the same as like O of n because we are going to have the same result as of this thing and also the one hash map as well. So not a big, I think so, thing to say. Let me just go back here. And what we're going to do is to iterate this. We are going to use E in strings. And now what we're going to do is to initialize our array to store the count, right? Because we are going to store the count that is actually like 26 characters from A to Z. Now what we're going to do for the hash map, now what we're going to do is to see like for example for C in like E, right? We're going to iterate this element character by character. And now what we're going to do is to use our ASCII to get the ASCII value of this. For example, let me just show you how what we are doing right now here because we want these things a lot. Uh, Let me just show you A equal to um we're going to store plus equal to increment. Yeah, because we are going to have the count. And then let me just show you what this actually means. This means, let me just go back here. Let me just take a screenshot and go here, what this actually does. So what we are doing here is we are trying to get the resultant ASCII value. For example, if it's E, we are like, for example, we if we are minusing like subtracting the A, the ASCII for this, I think so is 80 or something. What we can have in result, for example, let's say if we have A in the ASCII, for example, let's say we are iterating this E, right? We have like E, whatever the ASCII of E is, for example, let's consider, for example, 85, right? 85 minus 80, that is the ASCII value of A. We get 8, like 5 in result. This actually makes the iteration a lot easier because we get the value directly. We don't have to store the key. We only have to store the values of it. So this is going to be the thing. And then what we're going to do is to simply do this thing, hash dictionary. And what we're going to do is to use our tuple because in Python, you cannot hash a list like this. You cannot hash it. So that is why you need the tuple function on top of the hash function, on the top of the list you are using in order to, like use this in a dictionary or yeah. So this is going to be thing. So do remember this. This is very important. Or otherwise you will get an error regarding the hashing problem. So then after that, what we're going to do is to simply store, like what we're going to do is to simply append the E element and return the hash dictionary values because we just want the values. We don't want any dictionary key values here. So this is going to be a thing. Let's just run it once and let's see how it goes. Let's see if there is any error or something. Yeah, I think it's pretty much good. Let's just submit it. So I think it's all good here. So if you have any questions regarding this, do like comment it out in the comment section. And if you like the video, do subscribe to my channel and also like the video as well. So see you guys in the next video. Take care, guys. Bye.